going to be talking today about enhancing BGP. As Andy said, I only really got asked to do this yesterday, so if it's a bit rushed, I'm sorry, and if you've got some questions, I'm quite happy to answer them via email. If I can't, then I'm sure that somebody on a mailing list somewhere might be able to help me, so let's, I think we should kick off from here. So I think I make this point quite a lot. The BGP is more and more becoming a really key protocol already is a key protocol for pretty much every operator here. Pretty much everyone in this room is probably running it on their network, and if you're not, you probably want to look at it anyway. It's becoming more and more useful for signaling more and more protocols. There's VPLS that signal via BGP, there's VPNv4, there's VPNv6, and this kind of requirement is meaning that we need to make sure that BGP evolves to meet what essentially is our requirements. People in this room are the people that have the requirements for BGP. It isn't people that write protocols, it isn't vendors particularly, it's people that are running the network that are going to be needing features in protocols like BGP. So I'm hoping that I can kind of go through some of the drafts that are in IDR at the moment specifically, which is the Interdomain Working Group at the IETF, and introduce the concepts, kind of show you where they might be used, and either if you like them or you don't like them, or they seem to be introducing risks to the protocol, we can go and as an operator group represent this to the people that are going to implement these. The IETF working group, IDR working group, looks after BGP. It's kind of the group that works on the base specification. A lot of other working groups do contribute to it, of course, but this is usually where it's standardized. And I'm going to end with a bit of encouragement to get involved, which I guess I've already started with. So, as I've said, the IETF IDR is a working group at the IETF, which working groups at the IETF are just involved participants of whoever gets involved. There's no joining procedure or anything. It's if you want to contribute, you are a participant, and you are then a member of that working group. The makeup of the working group is from operators, vendors, and implementers. It tends to be that there's a lot more vendor representation on these kind of lists. The Cisco and Juniper have relatively high amounts of representation and write quite a lot of drafts. There's some implementers, the OpenBGP guys get involved quite a lot, but there's not that many operators. There's in general, it seems to be that only when people are specifically asked to contribute on specific drafts do they start contributing. So what I'd quite like to see is more people reading drafts and just feeding back on them. In the IETF, all ideas are kind of put into an internet draft. With IDR especially, if you want to slot at a meeting, you have to have a draft. So it doesn't necessarily, just because you've written a draft doesn't necessarily mean it's going to make it to RFC, or you even want it to make it to RFC. It can just be a way to say, hey, look at this. This is an idea, or this is a problem I've spotted. Please can we react to it? Please can we discuss it? The procedure kind of goes from a draft is then adopted by a working group, and the working group then works on it until it reaches what it thinks is suitable to become an RFC. It's proposed to then become an RFC. All the documents I'm going to talk about today are in a draft stage. Some of them are in a stage where they've been adopted by the IDR working group, some of them are not. So how I'm going to do this is kind of, if there's a draft relating to something, I'll probably introduce the idea behind it, or the key bit that I'm going to talk about, and then move on and show you what the draft does. As this says, I'm going to talk about BGP capabilities. Originally, BGP was only for IPv4 routing information. The original RFCs exchanged the original RFCs exchanged IPv4 routing information, and obviously this is that as we've evolved and had more protocols and more address families to support, there's been a requirement for us to start signaling other families. So the way that this was introduced was by one of the existing mechanisms in BGP, which is capabilities, which is where a neighbor can negotiate with the other speaker in the session as to what they want to support on the session. And pretty much everybody that runs BGP will be using capabilities, because things like graceful restart and route refresh are capabilities at the moment. The big one that is what most widely used is multi-protocol BGP. So you're running IPv4 and IPv6 as separate capabilities on the same session, and they're advertised and they're negotiated between the two speakers in the session at the start of a session. The other feature, some enhancements like the 4x8s stuff are also implemented as capabilities. So the first draft is draft IETF IDR dynamic cap. At the moment, if you've got a set of capabilities, you've got a set of things that you want to support, you send in your open message a list of the capabilities that are going to be supported on this session. Some negotiation occurs, but this is definitely only negotiated at the start of the session. So once I've set a session up to you, if I only support IPv4 in that session, for the lifetime of that session, that's all it's going to support. This obviously becomes a bit of a problem when something changes or you want some enhancements required, and this draft aims to remove the requirement for me to bounce the session to add some additional capabilities onto it. So, for instance, if I've got a POP that's IPv4 only and I want to push IPv6 out there, this draft would allow me to add IPv6 onto that session without it being without having to bounce the TCP session itself. The way that it's implemented is, at the original Open, there's a new capability that's discussed, which is dynamic capability, and a set of capabilities that you support within that dynamic capability. So you advertise, okay, this is a new session, I would quite like to be able to support, these are all the protocols that I support, so I'll support these for dynamic capability. Once that's been done, a capability message is sent between the two peers to add IPv4 or IPv6 or whatever is the requirement on there. One of my bugbears and one of the things that I've presented about previously is about error handling. So I always like to mention that there's some problems with error handling when you start to introduce such complexities to a protocol, like how do you react when the other side doesn't necessarily conform to the way that to the way that the standard's written. So this is the example that I just discussed. So I've got a POP that's got IPv4 only enabled. That's being established between in the open message. Currently, I need to tear down that session, which may or may not cause a forwarding outage to my sites, depending on how the configuration is. One of the global crossing architecture people pointed out that in some implementations where you've got common administration between two neighbors that say are your two uplinks to the core via BGP for this one box, you might need, by changing the policy for them, you might bounce both of them, so you will get a forwarding outage. So with this draft, you now say, okay, I want to activate IPv6 on this session, a capability message is sent, and the peers negotiate that we're now going to run IPv6 NLRI over this session. So it looks like there's a good operational case for it to be there. However, it's been adopted as an IDR draft. This tends to happen with things that have been around for a while or things that do look to be useful, and I think you can see why it has been. However, there are definitely pros and cons to it. The pro-wise, it does allow us to start adding new functions to BGP without being disruptive and without an operational impact, which is obviously of great importance to us because you really don't want to be able to enhance functionality on your network. It's not a good idea if you need to be causing an outage at the same time. However, at the current time, I think there's, I know that both me and Andy have been quite vocal about this on the mailing list, that we don't really trust vendors to be able to go and implement software that's very complex and where the standard isn't very well defined. And so if you've got a complex implementation, it almost by definition means that there's going to be more scope for bugs in it. So really, am I going to get more cases in which a notification is sent on my BGP session because the dynamic capability protocol was more complicated than it was just bouncing the session to start with? In addition, I'm not hugely convinced that this solves a problem that exists completely. If a vendor's, so in our network we have a box here that then peers, it's got its eIBGP sessions, and it's got some sessions out to a core AS or our kind of backbone AS. When we'd introduce new capabilities on this, bouncing one of the sessions isn't something that's a problem in our implementation. So can it be argued that really there's no requirement for it to have dynamic capabilities on the session, because you should just fix your implementation so that common administration doesn't bounce all upstreams? The next thing I'm going to talk about, which kind of runs in parallel with dynamic capabilities, is multi-session BGP. So at the moment, when you have a BGP session between two routers, they have a single TCP session between them. And at the moment, if your box doesn't support one of the drafts, which there's quite a lot of pre-standard work on this, definitely Cisco IOS in 12.2SR will support this and do it without you knowing. So between your two boxes, you've got a single TCP session, and over which you're exchanging messages. The draft I'm going to discuss introduces support for multiple transport sessions. So I can now have between box A and box B, I can have two sets of TCP sessions. The big motivations for this are to address some of the criticisms of BGP in terms of that it's very fragile. The really well-defined error handling is, if you're wrong, I'm going to send you a notification, and if I send you a notification, then I'm going to tear down a BGP session. So this is, which obviously disrupts all of the connectivity between two speakers. So we're looking this way to be able to send a notification just for a single session, which brings some robustness in terms of how we're going to, in terms of the connectivity between those two boxes. The other thing is at the moment, if I've got a single session between two neighbors, I can't distribute that between multiple processes. So it might be an advantage to be able to have IPv4 in a session in a single container and IPv6 in a separate container, so that I can manage control plane resources based on the importance of them to me. So here we go. I jumped the gun a bit. These are this is one of my deployment cases. One of the things that we note is that L3 VPN traffic probably makes us more money than IP traffic, because I can do some more features on that, and therefore I don't really care if my so I'd much rather my VPN v4 traffic is protected than my IP traffic is protected. So in the case at the moment, if I've got some update in the default free zone that I can't that's untrusted almost inherently, if this puts my BGPD in a loop or so, then I lose all my connectivity to that box, whereas I would much rather be able to handle that runaway process by prioritizing the VPN v4 traffic over my IPv4 traffic. I'm sure there was meant to be a 1 for the benefits, but I don't know where it is. So this is the draft that's currently going through the IDR. It's been written by John Scudder from Juniper, who writes quite a lot of drafts, and it's particularly clever. It's relatively mature. It's actually around in, there's some pre-standard support in a number of OSs. It's definitely an iOS, as I've mentioned. It isn't the only approach, though, and the way that it works is you can end up having more than one control port for your BGP. So this instead, I send a message to 179 and say I'd like to open a new multi-session session to you, and you can reply back and say, well, actually, I don't want you to talk to 179 anymore. I want you to talk to, here's a random port that's not in use. That obviously has some implications for COP, because I would quite like to be able to have if it's coming to 179, it's relatively important, and if it's coming to 179 from these addresses, then it's relatively important, and this is BGP traffic, so please don't ever drop this on the way into my control plane. However, this draft does add a new local port for each new connection, or is one of the options. If you look on iOS at the moment, it won't actually do this, but it's given that it's one of the options and one of the ways of process distribution, then perhaps it's. I think this is a bad thing, really. There's the operational complexity of trying to maintain which of these connections are BGP. If there's not some automated method to be able to build a COP policy, is quite difficult. So Ilya, who works at EasyNet, has written a draft which I think it was in the last couple of weeks or so, and it kind of describes an approach to be able to multiplex sessions onto 179, where the OS distributes the session based on what it was, the process it handed to start with. It's quite a complicated draft because Ilya's put a lot of options in it, and it's definitely pre-standard by a long way, but it's one of the things that operators, I think, should be supporting, because vendors don't have to build COP policies, whereas we probably do. Okay, this is moving on from multi-session, and this is there's a draft in the IETF called additional paths at the moment. At the moment, if I've got a root reflector, say, and it receives two prefixes that are the same prefix, it's got two paths to it, my root reflector is going to make a best path choice and advertise it onto router 3 in there. So router 3 forwards traffic at either router 1 or router 2, and it doesn't necessarily matter which, but for this case it's forwarding it at router 2. If the path to router 2 is withdrawn, which might be a upstream decision or so, I have to wait for convergence before the new best path is advertised to the PE, to the RTR3 in that diagram. So that obviously there's some convergence delay, and it might be that in that time I get a forwarding outage. So the current behavior is that there's one path per prefix. If you're advertising onwards, you only ever advertise one. As soon as you send an update for that prefix, then it's treated as an implicit withdrawal at the other side. The other side goes, okay, you sent me an update for this, thank you very much. I'm going to replace the path that I already installed relating to this. But this does mean that we need to have an update to be able to converge. The other application is that if I'm a box that does take two paths and install them both into my fib, then I can load balance across the two. If I've only got one path from my upstream box, then I only have one path on which I can load balance, so I can't load balance. So the idea is that, so that's a limitation of having a single path. So with the additional paths, we basically take the idea of a VPN v4 RD, which is a kind of tag that goes with this prefix, and introduce that. So I advertise a path with path ID 1 and one with path ID 2, and they're both at the same place, but I'm now advertising two prefixes upstream to you. The path ID being different makes sure that that when I send an update, it's actually not an update for the existing prefix because it's a new path. So I can now advertise multiple paths upstream to appear, which obviously starts to solve some of the problems that I just discussed. However, there are also some downsides, as there are with anything like this. If I'm going to hold multiple paths, then every time I go through and try and work out which the best path is, I've got more candidates to go and consider, so there's more kind of CPU usage. The other thing is that I'm going to end up with some control plane resource used. I've got to use the memory to store all these paths in my control plane, which I'm not necessarily actually going to use for anything other than convergence or load balancing. The other thing that someone's pointed out to me today is that it's not necessary that you actually need support for this in almost all of your network before you can deploy it. At the PE that's going to do fast convergence via this mechanism, it needs to support it. Your root reflector needs to support it, and anywhere where it's not, and it's got two paths and doesn't advertise them upstream, you don't end up with it converging quickly. So unfortunately, it tends to be a relatively long. It's a relatively difficult draft to implement from scratch. However, there is also another draft that someone at Cisco has written that kind of describes how you can do this by just running two root reflectors that have got different identification, so that they advertise two paths upstream. So in my the two new things that I get from this draft are if I've got a router there that's forwarding it to next hops, something in the middle signals that one of them's gone away. For instance, I get it drops out of my IGP, then I can quite quickly converge to the other path rather than having to wait for an update to tell me what the new path would be. At the bottom is the ECMP type idea. I've got two paths advertised from my root reflector, and I can now forward at both the next hops rather than just making a selection of one. This is, now going to move on and talk a bit about error handling. I'm not going to talk particularly about very specific drafts here, and then not really explain what they do in that greater detail. But these are things that I have presented about before. I think I presented at a Links meeting a while ago, and there's some video on my site if you want to watch me. So the first draft here is to react to optional transitive attribute errors. So at the moment, there's a very catch-all type error handling case that this is an error, send you a notification, and even though this was routing metadata, you tear down the session. This obviously is not necessarily that great because I can get an error from a distant AS that no one in the middle checked, and I tear down the session. It's obviously quite harmful in terms of keeping connectivity. So that draft is I think is well established in there being a requirement for it within the working group. The next draft is something that Tom Scholl put together, and since then a number of people have worked on, about a new capability in BGP, which is the advisory capability. It starts to introduce message passing in a human-readable form between two neighbours. So I can either send a sticky notification, so on open I can give you a message that's displayed in your show output somewhere relating to my neighbour, or I can send some in-band signalling. For instance, if I'm going to upgrade the software on my box, I can send you, actually, please don't call my NOC, this is a software upgrade, here's the maintenance reference, which means, hopefully would mean that you look in your logs and you see, oh look, this went down, there was the reason. It's quite a nice idea. I think some people are against it because they don't like the idea that you might be able to use BGP as an IM mechanism, but you know. The other thing that gives you is it kind of ties into the optional transitive type errors. If there's an error where I'm withdrawing or discarding a path from my table, it'd be quite nice if I could tell the BGP speaker on the other side that I'm no longer using this path because it's got an error in it. Because right now, if I'm propagating an error upstream and the other side's ignoring it, there's absolutely no way that I know about that. These two came from a discussion with Tom Hodgson last night, where he pointed out that people probably care about these two, so I'll mention them. BGP MIB v2, we're in the 10th version of this, and it's been around for a long, long time. And I think we were discussing that we can't believe that in this day and age, there's no way you can look at received routes via SNMP on your router. And the other thing is, there's no IPv6 support. I mean, I really love having the first 32 bits of the v6 address as the only ID. It gives me an SNMP. But I don't think very many people do either. It's great if you've got one BGP neighbour, but the rest of the time it's not really that useful. So hopefully this draft will one day make it to standard, or we'll get some pre-standard implementation of it, which will mean that we're going to start having a proper MIB that supports more BGP activity. I think that it's been thrashed out what it should do, but I think if I'm guilty of this myself. I haven't read through it and properly chased it, but I think as operators, if we're going to start deploying v6, there's no way we're not going to need this. So it would be really great if we could support it. The next draft is about extended communities. So there's an existing capability to offer communities that are 8 octets long, I think, and a number of them are used for, some of them are used for the length, and also this is so the idea is here we'll be able to use 4xAS before the community portion of the community. I think given that the standard identifier is your AS colon your local meaning, then as we deploy 4xAS, there's definitely going to be a need to have it. So again, some op support would be great. The one thing, there's been some comments around how suitable this is and how it fits into existing community deployments, but I think personally that there's not very much we can do, and we should just get this pushed to standard as soon as we can. And me on to encouraging. Lots of vendors. It's very difficult to argue that operators care about X when you're one operator. And the vendors say, well, operators don't care about X because nobody is asking us for them. So the way that vendors are typically driven is stuff goes in an RFP and it gets implemented because they want to meet that RFP. But you have to be quite big for that. So given that we're the people using the features, it would be great if we feedback to the place where the standards are developed what we want. And we're the people that use the features, so it would be great to kind of push them as much as we can. And it's really not hard to get involved. I think I've subscribed to maybe 10 ITF mailing lists. I don't read every one of them religiously, but reading something like IDR, is not a big task. There's not very much mail on it, and you can always dive in where you want. I don't think there's any problem with dredging up an old thread because you suddenly had a new thought on it. So it would be really good to get more people involved in this kind of thing, because it's only in numbers that we're really going to have have any kind of input or any further input. And also, it kind of keeps the vendors honest in terms of keeping what features are implemented. We can't say, well, we wanted this feature 5 years ago, when there's been no involvement from us in a forum where it's very open and we can go and help develop it. Questions, comments, corrections? I encourage the corrections one. Hello, Thomas.
Hi, Rob. I am slightly puzzled about the multiple session. As far as I'm aware, if you have a BGP speaker and you speak to a router and start two connections to it from the same IP address, they will have different source ports, and as long as you put a different identifier in the open, both sessions will stay open. I use it every day on my network.
So this is a little bit more to, so I can have two sessions open, but if I want to be able to have as kind of a policy thing to say, this session is going to carry this address family.
You can do that. If your code does do that, my code I use, I have from one machine, I have one session for IPv4 only and one session for IPv6 only. I have my own code, so I can do whatever I want, but I open with
This is with the same router ID specified in?
No, yeah, different IDs.
Router ID.
Yeah.
Okay.
But with the same machine sourcing the information.
Sure, so, but I guess the way that you have duplicate detection in BGP is going to be based around the router ID.
Yes, it is.
So really what you're doing there is saying, I'm a logical system on this box
Exactly.
also.
Well.
So I guess if we, this draft just does that, but in a way that means you can have a single router ID, right?
Okay.
Whether or not that's the most useful way.
Doesn't make my day.
Hi Rob, I've a question and a comment. The comment is that you left out one rather important feature of AdPath for IXP operators, and that is that if you're running a root server and your client supports AdPath, there's no longer any need for the root server to maintain a separate lock rib, which means that if you can get all of your clients to support AdPath, then your operational resources for running the root server are actually massively reduced. So this is a huge, huge performance win for root server operators.
Didn't think of that at all. It's a brilliant point.
On the multi-session BGP, so okay, you've got a primary BGP session or an initial BGP session or whatever it is, and you start negotiating port numbers and addresses and stuff like that in the session. Somewhere, someday, some absolute idiot is going to want to run this through NAT. Is there any mention in the draft about doing this harebrained idea? You know it's true.
I think the lovely thing about not having to think about ops when you're a protocol developer is you go, oh, no one's ever going to want to do that. So you don't do it. I don't think there is any mention of this. I would strongly discourage it, and I advise all my competitors to do it this way.
I have a great news. You can use BGP for NAT nowadays, and it works.
Thomas, it's something that nobody needed to know.
I have to test it.
Thanks very much, Nick.
So I don't think the NAT thing's such a crazy idea, especially if you think about big organisations moving providers. And I know we've used NAT in the past to get around issues about where to route stuff and migrating from one service provider to another. So it may sound like extreme, but in VPN land where you've got a different kind of environment, it's not as crazy as you might think. Hopefully, to be honest, the NAT solution isn't ideal in that scenario either, but I wouldn't ignore the fact that it might be less crazy than you think. But
I guess my argument there would be maybe you want to encourage your customer to just renumber the outside type. How you inject prefixes in. without having to change the internal infrastructure. But it is a good point, because obviously we all come across these things where you can't, you know you don't want to do it, but you've got to because that's what the customer wants.
Thank you. Any more questions for Rob? Everyone's looking very content, so
I think I got.
well done. Thank you.
So my contact details are up there.